Good afternoon, ma'am. In previous class we have seen what about that hydrogen spectrum, that line spectrum of hydrogen we have seen. Now just once I will recall that hydrogen spectrum, and after that I will go through next one. See, if an electron jumps from n is equal to 7 to n is equal to 1, remember that formula yesterday I gave. That formula is n into n minus 1 by 2. Okay, that formula is valid when higher energy is whatever it might be, 6, 7, 8, whatever it is, but lower energy must be n is equal to 1. Higher energy can be anything, but lower energy must be n is equal to 1. Then only this formula is valid. Okay, now when electron jumps from n is equal to 7 to n is equal to 1, how many lines we will get? Okay, that is number of lines equal to 7 into n is equal to 7, substitute there, 7 into 7 minus 1 divided by 2, 7 into 6 by 2, 2 3s, 7 3s, 21. How many lines we will get? 21 lines we will get. If electron jumps from n is equal to 8 to n is equal to 1, then we will get number of lines. Number of lines equal to 8 into 8 minus 1 by 2, 8 into 7 by 2, 2 4s, then 4 7s are 28 lines. Like this examples I gave, okay, we can find for any sort of thing. In problems there is a chance to be asked. Okay, so remember that formula carefully, n into n minus 1 by 2. Okay, and one more thing, that scientist series are there, na? Series, that series also we have to remember carefully. Okay, see once. N is equal to infinity to n is equal to 1. That is Lyman series observed in UV region. Next, n is equal to infinity to n is equal to 2. N is equal to infinity means whatever it is. See, n is equal to 1. Lower energy is fixed. Higher energy might be 2, 3, 4, 5, 6, etc. up to infinity. Whatever it is. If lower energy is n is equal to 1, then that series is called Lyman series. Okay, whatever the higher energy might be, 3, 4, 5, 6, 7 and so on infinity, up it comes to n is equal to, lower energy is fixed with n is equal to 2. Then that series is Balmer series. And this is observed in visible region. N is equal to infinity to n is equal to 3. Paschen series. Paschen series, this is observed in near infrared region. Next, n is equal to infinity to n is equal to 4. Bracket series. This is observed in IR region. Next, n is equal to infinity to n is equal to 5. This is observed in Fund series. Fund series, and that is far infrared. Okay, this n is equal to infinity meaning here this is 2, 3, 4, etc. Here 3, 4, 5, etc. up to infinity. This is also up to infinity. Whatever the higher energy might be, if lower energy is fixed with n is equal to 1, then that is Lyman series. Whatever the higher energy might be, if lower energy is fixed with n is equal to 2, that is Balmer series. Next, whatever the higher energy might be, that is 4, 5, 6, etc. up to infinity. If lower energy is n is equal to 3, that is Paschen series. Next, 5, 6 and so on up to infinity. This is bracket series. here 6, 7, etc. up to infinity. Okay, these are the different series. If it is lower energy, n is equal to 6 ma. If it is lower energy, n is equal to 6, another scientist is there. But up to these 5 scientists, it is okay. Okay, see, n is equal to 1, higher energy to n is equal to 1 was studied by Lyman. N is equal to higher energy to n is equal to 2, that is studied by Balmer series. Balmer. Okay, this higher energy, whatever it is, lower energy n is equal to 3, Mason. Like this, different scientists have studied different lines, but all these lines were successfully explained by Niels Bohr, and all these lines are formed on the screen like a discontinuous spectrum, because between one line and another line there is a gap. Between one line and another line there is a gap. That's why that is called discontinuous spectrum. Okay, ma? That is called line spectrum of hydrogen. That is explained by Niels Bohr successfully. Okay, this is about Niels Bohr hydrogen atom, hydrogen spectrum, line spectrum of hydrogen. Okay, ma? We have seen that 4 successful explanations given by Niels Bohr. Formula of angular momentum of an electron, MBR is equal to NH by 2 pi. Second one, radius derivation, radius of enthalpy derivation. Third one, energy of enthalpy derivation. And fourth one, line spectrum of hydrogen. First we have completed line spectrum of hydrogen. Is it okay? First we have completed line spectrum of hydrogen. Next we will go through radius of nth orbit, energy of nth orbit. Let us see that one. Okay, just observe this everything ma. Yesterday I have given the diagram. The diagram is also very important. Please understand the concept carefully. Each and everything clearly I explained. If you have any doubt, immediately you can ask me through WhatsApp, no problem at all. But you have to be clear about the concept. Okay, once observe this one, all of you. Okay, next. Second one, radius of nth orbit. Radius of nth orbit. Okay. Radius of nth orbit derivation was explained, but in your textbook the derivation is not there. Okay, but even though if you are interested to learn the derivation or to see the derivation, if you say to me, I will write on a paper and I will send to you, or otherwise I will download and I will send to you. But 1 minute man, that is not correct. If you say to me through WhatsApp you want derivation like that, next class I will say the explanation. Okay, but in this class we will go through the formula directly. Once again I am explaining, radius derivation and energy derivation was not given in your textbook. Definitely the derivation, how it is derived like that, the derivation is not given in your textbook. Okay, it's simply we want formula. Okay ma, now let us see. Radius of nth orbit Rn is equal to 0.529 into n square by z angstroms into n square by z angstroms, where n is equal to number of the orbit, z is equal to atomic number. Radius of nth orbit Rn is equal to 0.529 into n square by z angstroms. Angstroms, 1 angstrom is equal to 10 power minus 8 centimeters, which is equal to 10 power minus 10 meters. That is the conversion. This is the unit of distance, length or anything. Okay, 1 angstrom is equal to 10 power minus 8 centimeters, which is equal to 10 power minus 10 meters. That is the relation between angstroms and centimeters. This is the formula of radius of nth orbit. Okay, now let us see. Li plus 2 ion they give. Li plus 2 ion. Okay, they asked radius of first orbit. For this Li plus 2 ion, they asked radius of first orbit. Okay, like this the question is given. Okay ma, now let us see. First, what is the given data we have to see. N is equal to 1 because this is first orbit na? See, N is equal to number of the orbit. Orbit number is 1. So I took N is equal to 1. Next, Z. What is meant by Z? Atomic number. Lithium atomic number 3. Lithium atomic number is 3. So Z is equal to 3. N is equal to 1. First orbit they give. Z is equal to 3. Li plus 2. Okay. Next, angstroms like that, keep like that only. Now R1. This is general formula Rn. What is meant by N here? Number of the orbit. That number of the orbit 1 only. So R1 is equal to 0.529 into N square by Z. What is the N value? 1 square divided by Z, 3 angstroms is equal to 0.529 divided by 3 angstroms. If you solve this question, you will get 0.3 will cancel 1 times, then you will get 22. Next 7 times. Next 119 6 times. 0.196 angstroms. What is that? 0.196 angstroms. So in Li plus 2 ion, this is positive charge nucleus, first orbit. This is radius of first orbit only. This first orbit is 0.176 angstroms distant from nucleus. This is nucleus, but this is first orbit in Li plus 2. In Li plus 2, that is the first orbit. Okay. Now, that first orbit in Li plus 2 is 0.176 angstroms distant from nucleus. That is the meaning. 0.176 angstroms distant from nucleus. Okay. This is the example. One more example we will see. Okay, ma, are you clear? So this is the formula, very important. Rn is equal to radius of nth orbit is equal to 0.529 into n square by z. 0.529 into n square by z. Okay, where n is equal to number of the orbit, z is equal to atomic number. I will take one more example, ma. Let us see. In BE plus 3 or BE plus 2, anything, no problem. In BE plus 2, find the radius of second orbit. In BE plus 2, find the radius of second orbit. That one we want to find. In BE plus 2, radius of second orbit we want to find. What is the given data? That is n is equal to 2. What is the given data? N is equal to 2. Next, Z is equal to beryllium atomic number is 4. Atomic number of beryllium is 4. Okay, so Z is equal to 4. N is equal to 2. Z is equal to 4. Okay, now substitute these values there. Then we have to find radius of second orbit means R2 only. N means 2. R2. R2 is equal to 0.529 into N square 2 square divided by Z value 4. Hydrogen, helium, lithium, beryllium. Beryllium atomic number is 4. Okay ma? Now substitute these values. 2 square by 4. 2 square 4. 2 square means 4 only. 4 got cancelled. We are remained with 0.529 angstroms. 0.529 angstroms. In this way we can find radius of any orbit present in any atom. In this way we can find radius of any orbit in any atom. Okay ma? I hope you are clear about this one. So what is the formula we are using here? Radius of nth orbit Rn is equal to 0.529 into n square by z angstroms, where n is equal to number of the orbit, z is equal to atomic number. Okay, 1 angstrom is equal to 10 power minus 8 centimeters equal to 10 power minus 10 meters. In Be plus 2, radius of second orbit we found, that is R2 is equal to 0.529 angstroms. Okay, now I will give some examples. Try to do them in your homework. Okay, let us note down. First one, in Be plus 2, find the radius of first orbit. In Be plus 2, find the radius of first orbit. Next, second one, in Li plus 2, find the radius of second orbit. Third one, in He plus 2 or in He plus, find the radius of first orbit. In He plus, find the radius of first orbit. By using the formula in angstroms, you can find these three. These three, let us take this one as homework. Okay, what are those? In Be plus 2, find the radius of first orbit. In Li plus 2, find the radius of second orbit. In He plus, find the radius of first orbit. Okay, these are the things you have to do homework on your own. Please try to do with the help of formula only, but you have to be clear what is the n value here 1, here n value 2, here n value 1. Atomic numbers you have to be clear. Beryllium atomic number 4, lithium atomic number 3, helium atomic number 2. Okay, that atomic numbers and that one, if you see, substitute the values and you will get the answers easily. Okay ma? This is about radius of nth orbit. That radius of nth orbit derivation was given successfully by Niels Bohr without experiment, by doing theoretical mathematical calculation. Okay, Niels Bohr calculated the radius of nth orbit. You can understand how atom is very small. Okay, suppose this is atom. This atom itself, it is very small. In that half of the distance he is able to calculate. That is nothing but radius. He is able to calculate half of the atom. That means radius of the atom. That means how much great explanation was given by Niels Bohr. That is the greatness. Even experiment is not conducted by using mathematical calculations and physics. Okay, he successfully calculated radius of nth orbit for any atom. This is second successful explanation given by Niels Bohr. Okay, ma? Next, energy. Let us see that energy also. Third one, energy of nth orbit. En. Energy of nth orbit En is equal to minus 13.6 into Z square by n square electron volt. Energy of nth orbit. Even this energy of nth orbit also, he has used the mathematical calculation and he derived. That derivation is also there, but the derivation is not given in your textbook. Definitely. Okay, if you want one class, I will teach for you, no problem. If you say, definitely, but little bit mathematical calculation is there, you have to understand. That is the thing, suggestion I will give. Okay, ma? Now, energy of nth orbit En is equal to minus 13.6 into Z square by n square electron volt per atom. This is one atom per atom. How much energy is there? Okay, where n is equal to number of the orbit, Z is equal to atomic number. En is equal to energy of nth orbit. Okay, this is the thing about energy. Simplified formula. This one you can keep it in box, ma. Even Rn also you can keep it in box. Rn formula. Okay, energy of nth orbit En is equal to minus 13.6 into Z square by n square, where n is equal to number of the orbit, Z is equal to atomic number. Okay, ma? This is about energy of the orbit. This derivation was also successfully given by Niels Bohr. That is really great. Without knowing the atom size, he is able to give half of the atom size by using mathematical calculations. Okay, as well as physics also. And without knowing that atom also, he is able to give, if electron is present in first orbit, what is the energy? If electron is present in second orbit, what is the energy it contained? Like this En value we can find. Okay, ma? Now one example. Energy of electron in second orbit of Be plus 2. Example, for example, I am telling the energy of electron in second orbit of Be plus 2. Okay, what is the given data? N is equal to 2, Z is equal to 4. Why did I write Z is equal to 4? Beryllium atomic number 4. Beryllium atomic number is 4, N value 2. Okay, now what is the formula? En is equal to, En means here 2 ma. Number of the orbit 2. E2 is equal to minus 13.6 into Z value 4 square divided by n square, 2 square is equal to minus 13.6 into 16 by 4, which is cancelled as 4, is equal to minus 13.6 into 4 ma, which is equal to 4 6 are 24, 4 3 is 12 to 14, 4 1 is 4, 54.4 electron volt per atom. Minus 54.4 electron volt per atom. That is the example we give for your understanding purpose. Okay, and what is the formula? Energy of nth orbit. See to that board, all of you, carefully. Energy of nth orbit En is equal to minus 13.6 into Z square by n square electron volt per atom, where n is equal to number of the orbit. Okay, Z is equal to atomic number. Energy of electron in second orbit of Be plus 2. Example I give, n is equal to 2, Z is equal to 4, then E2 is equal to minus 13.6 into 4 square by 2 square is equal to minus 54.4 electron volt per atom. Okay, ma? That is about this third one, energy of nth orbit. Okay. Now, what are the points, successful explanations given by Niels Bohr? Once again I am writing now. First one, MVR is equal to NH by 2 pi. Formula alone he gave, derivation was not given. But formula he gave, MVR is equal to NH by 2 pi, but derivation was not given. Second one, radius of nth orbit 0.529 into n square by z angstroms. Derivation was also given. Third one, En is equal to minus 13.6 into z square by n square electron volt per atom. Derivation was also given. Fourth one, line spectrum of hydrogen was successfully explained. These are the successful explanations given by Niels Bohr. These are the successful explanations given by Niels Bohr. Okay, ma? Now we have to see the drawbacks. What are the drawbacks? Drawbacks. First one, derivation for MVR is equal to NH by 2 pi. How this formula came? Simply he gave MVR is equal to NH by 2 pi. H is equal to Planck's constant. N is equal to number of the orbit. Everything okay. But derivation was not explained. So Niels Bohr couldn't explain derivation for MVR is equal to NH by 2 pi. This is first drawback. Second drawback, fine line spectrum of hydrogen. First one, derivation for MVR is equal to NH by 2 pi was not explained by Niels Bohr. Second one, fine line spectrum of hydrogen. Hydrogen actually he explained spectral line spectrum, but fine line spectrum is there. That one also I will give clarity. These drawbacks were not explained by Niels Bohr. Sorry, these points were not explained by Niels Bohr. Okay, next, third one. He couldn't consider wave nature. He couldn't consider wave nature of electron. Third point, he couldn't consider wave nature of electron. Okay, next, fourth point, why electrons are not losing energy in a particular orbit. This point was not explained. See, derivation for MVR is equal to NH by 2 pi. Fine line spectrum of hydrogen. He couldn't consider wave nature of electron. He did not consider wave nature of electron. Fourth point, why electrons are not losing energy in a particular orbit. Actually, he told electrons are revolving around the nucleus in different orbits without losing the energy. Those orbits are called stationary orbits. But why those are not losing energy? Why those are not losing energy? that explanation was not given by Niels Bohr. Okay, these are all points are explained by considering wave nature of electron. All the points, drawbacks of Niels Bohr were explained by considering wave nature of electron. That is the very important point we have to consider, but it was not considered by Niels Bohr. That is the main drawback he has done. Okay, ma? So successful explanations we have seen. Drawbacks of Niels Bohr we have seen. Main drawback is he didn't consider wave nature of electron. Then in next class, what is that wave nature? First I will explain what is that wave nature. What is that wave nature and how it is correlated to electron. Okay, what is that electron wave nature and how we are going to derive all these things, we will explain in next coming classes. Okay, ma? That is about today's class. See the drawbacks of Niels Bohr once. First one, Bohr couldn't explain derivation for MBR is equal to NH by 2 pi. Second one, fine line spectrum of hydrogen. Third one, he couldn't consider wave nature of electron. Why electrons are not losing energy in a particular orbit. For everything we will get answer by considering wave nature of electron. Once again I am repeating, ma. For all these drawbacks we will get answer by considering wave nature of electron. Okay, before going to know the wave nature of electron, first what is meant by a wave we have to know. That wave concept tomorrow I will start, means next class I will start that one. From that wave we will get electromagnetic radiation, spectrum, everything. After that we will go to these derivations. Okay, ma? This is about today's concept. I hope you are very clear about this one. If you have any doubts, ask me. Even that radius derivation and energy derivation you can ask, no problem. But the thing is they are involved with some mathematical equation, ma. Actually those are not present in your textbook. But if you ask me, definitely I will explain one class. Okay, ma? That is about today's class. Thank you. Thank you all.